YouTube is actively hiding something about their algorithm, something which I believe is directly related to how the algorithm decides which videos to promote and which to kill. In fact, I have proof that this is exactly the case. Although YouTube goes out of their way to make accessing this information very difficult, I have found a way to do it, and I used it to analyze my own videos. In this video, I'll show you all the data points I extracted, public, private, and even hidden, and which ones seem to be the defining factors when it comes to the YouTube algorithm deciding whether to push a video to a larger audience or not. Stick to the end to find out which singular indicator you can use to predict whether YouTube is about to start promoting your video or simply let it slowly decay into irrelevance. We already know that YouTube cares a lot about three performance metrics: average view duration, click-through rate, and more recently, viewer satisfaction, which YouTube measures through surveys. Although we can get the first two directly from YouTube Analytics, we can only estimate the number of viewer satisfaction by measuring something like the ratio between views and the number of likes, new subscribers, and shares a video gets. It makes sense that when more people are satisfied with a video, we can expect to see a higher number of likes, subscribers, and shares compared to the number of views it gets. Initially, the plan was to use YouTube's data and analytics APIs to investigate thousands of videos and understand what makes them go viral and why. I was then going to use this information to build an AI that predicts the number of views new videos are going to get based on their initial performance, or in some cases, even before they were published. But while I was researching this, I was surprised to discover that a lot of data is missing from both YouTube's public and private APIs. Data that is seemingly important to understand how videos perform. Impressions and new viewers are two of those metrics that are important but are missing. Curiously enough, they are available in the Creator Studio for content creators to see, but conveniently missing from the APIs. This basically means that YouTube is okay with showing this information to content creators, but does not want any puny programmers, data scientists, and researchers to dig any deeper and discover things they are not supposed to. This naturally piqued my curiosity, and I decided to pause my initial plan for now at least and focus exclusively on this clearly hidden information. YouTube has presented a challenge and I have accepted. So I got to work. To get the data, I simply accessed my own Creator Studio and saw what packages YouTube was sending to the dashboard. I found some data that seemed to be what I was looking for. I wrote a script to read and render them, and voila.
Ladies and gentlemen, we got them.
Impressions, new viewers, returning viewers, all the missing data I needed, I now have. Now it's time to investigate and see what we can find. First, I compare 3 of my own videos based on their performance during the first week. I want to see if there is any initial evidence that hinted that my first video was going to go viral and why my worst performing video did not ever pick up. As expected, the average percentage viewed and the click-through rate for the third video are very low, which might be the sole reason why YouTube never got interested in promoting it. But what about the viewer satisfaction? As we can see, the viral video had a better likes, subscribers, and shares to views ratio than the other two. The differences between the 3 though are not so clear when it comes to the ratio between shares and views, which got me thinking whether the number of shares should be included when estimating user satisfaction. Now I'm about to incorporate our hidden metrics into the equation, so start paying attention. What happens when we switch views with the number of impressions instead? Well, the evidence becomes a lot more clear. It takes a lot less impressions for our soon-to-be viral video to gain new subscribers and likes. We also validated that the number of shares is irrelevant in this context at least, and should be discarded from any further investigation. When we combine the number of new viewers with impressions, the difference between our viral video and the worst video becomes even more evident. So, how many likes, new viewers, and new subscribers impressions drive seem to be important metrics for the YouTube algorithm. It makes a lot of sense for YouTube to want to drive new viewers to your channel that are more likely to be interested in your content and therefore end up subscribing too. So from this point forward, I'm going to focus on these 3 indicators as I dig even deeper into the data. And trust me, you're gonna want to see what I discover. Let's take a look at the first 90 days of my viral video and how the number of impressions, aka how much the algorithm is promoting the video, changed over time and why. Specifically, I want to see how a variety of metrics today is correlated with how many impressions the video is going to get 30 days from now. In other words, which of the metrics are more likely to be responsible for the future performance of the video. After running my code, this is what we get. The closer to 1 or -1 a metric gets, the more correlated it is with impressions. That is why impressions has the value of 1, since it is 100% correlated with itself. Take a closer look. What do you notice? The usual suspects, which are average view duration and click-through rate, seem to be strongly correlated with impressions. So once again, we validated that those 2 metrics are indeed important. And what's this? The ratios between new viewers and subscribers with impressions are also strongly correlated. Our initial intuition then seems to be correct. So let's focus on these 2, go even deeper, and have some real fun. This is where the real discovery happens. In light purple, you can see the number of impressions the video received in the first 90 days since published. This is the number of new viewers each day, and this is the corresponding number of new subscribers. You can now visually see that these 2 metrics are indeed correlated with impressions. If we now take their ratios, you can see some evidence of a causal link too, meaning that the new viewers and new subscribers seem to have a real effect on the future number of impressions. In contrast, the ratio of likes and shares with impressions, which we have already discarded, does not seem to have any effect on the algorithm's decisions. The only thing that is left now is for us to find a way to take advantage of this information. You see, the true insight lies in the difference between impressions and the corresponding new viewers and subscribers. The value of this difference significantly affects the decision of YouTube's algorithm, and I'm about to prove it. I created 2 new metrics with these differences, and these are their graphs. And here is where the true discovery lies. You see, whenever these differences are low and closer to 0, the algorithm takes this as a signal to push the video further to a larger audience. When the difference starts increasing though, the algorithm decelerates the promotion of the video and the impressions start falling. In simple words, there's an inverse relationship between the 2. But why is that so? And does it make any sense? Let's use the number of new viewers to explain the logic behind it. Based on what I have seen, I believe that the algorithm wants to promote videos where the relationship between impressions and new viewers is 1-to-1. In other words, where the video is scalable. Meaning that if the algorithm increases the number of people it shows the video to, we want to see an almost identical increase in the number of new viewers and new subscribers. When this 1-to-1 relationship breaks, like my voice just did, the algorithm starts holding back to re-establish this balance, and the video slows down. But wait, there is one more thing. I wanted more concrete evidence that this difference metric is indeed important. So naturally, I created an AI model that uses all these metrics to predict the number of impressions a video is going to get 7 days in advance. I then reverse engineered the AI to see which of the metrics were the most important in its predictions. And there it is. The difference between new viewers and impressions is the most important metric, followed mostly by viewer satisfaction elements and your usual suspects. So I can say with increased confidence that our findings have at least some significance. Having said that, you must keep in mind that the sample data is not large enough to make conclusive statements. So take everything you've seen in this video with a grain of salt. But do not worry, in my follow-up video I'll go even deeper, I'll investigate thousands of videos, I'll use more advanced AI, I'll do anything necessary for decoding the YouTube algorithm. Until then, stay hungry, stay foolish, okay, bye.